The Edifice Complex podcast is brought to you by DCM, the Drawing Specialists, Blue Rhythm Commissioning Software, and Sensor Suite, the future of intelligent buildings.
Welcome to the Edifice Complex, the property design and development podcast. Let your hosts Adam Muggleton and Robert Bean keep you up with who is innovating and doing great work, perspective on the adjacent possible, and challenges to the status quo.
Welcome to the Edifice Complex. I'm Robert Bean, your co-host and unofficial mediator. We're here with my colleague, official agitator, friend, and Yoda of most everything to do with buildings, Mr. Adam Muggleton. Say hello, Sir Yoda.
Hello. So I am interested in today's conversation because this is one of my favorite pet subjects. Useful books, right? Books that actually tell you how to do something, not try and show you how clever the author is, but actual useful books. So this should be an interesting one.
Yeah, so today's guest is a professional engineer from Charleston, West Virginia, one of my favorite places. He's a programmer, integrator, and author of a number of publications, including a relatively new book titled BAS Input and Output Devices, part of the Fruit Cove Commissioning series. The book provides a description of hands-on testing, tools, methods, and strategies that are employed in the commission and building automated systems. Welcome to the show, Francisco Valentine.
Glad to be here. Thank you.
Francisco, you graduated from West Virginia University, first with a Bachelor of Science in Mechanical Engineering, then went on to earn your master's degree, also in Mechanical Engineering. And over the course of 30 plus years, you've really sunk your heart and soul into the real sort of a diverse field of engineering and controls. I mean, as soon as you get into controls, you're into a whole bunch of areas of engineering. Right?
That's for sure.
We're certainly looking forward to hearing your story because unlike a lot of people we've had on the guest show, your brain and your mind have taken you into a whole bunch of different areas when it comes to controls. So how did you get to where you work today?
I think I have an overly active and hungry mind. And it seems like when I get bored with something, I want to change. So my first job out of university was I was a pipeline engineer. I took care of underground natural gas lines. And the most complicated thing there is cathodic protection. But, after doing it, I think 7-8 years, I got really bored. And while studying for the PE and finishing up the master's degree, I revisited all the heating and cooling problems. And I said, you know what, this is what I want to do. It's more interesting. It's way more sexy than pipes. Pipes, all you have to know, if you have a diameter, it has to have a certain thickness, to hold the pressure in. So I moved on and went to work for an HVAC design firm, and I did HVAC design and plumbing design as well. And at the time we were being purchased by UNESCO. So, all the single guys got sent to military bases and college campuses, wherever they had lots of buildings, and we would survey those buildings to find energy savings. And they said, well, you know the most about the job. How about you commission it? So I had to look up commissioning. It's like, what is that? And so the only references that I could find were related to the Navy, where they would commission ships. So, and I said, well, what do they do to commission ships? So they do exactly what we do in building automation. They go from component to component, to system to system, the inner system to inner system, communication line, and they verify that it all functions as designed. And along the way, I got into balancing and learned it enough to know that I didn't want to be a balancer. But I kept the certification, so and the knowledge, and it seems like this kind of unique blend of design, commissioning, energy, controls, knowledge kind of helps you see things in a much different light than other people may. And as a commissioning guy, you're supposed to be the expert on all of the facets of commissioning. And not everybody can fill that bill. Like a lot of design guys go into commissioning, so they're in tune with all the design issues, but they're not so in tune with piping, the choice of swing versus a flow check, and or even the types of sensors that you would use in different applications. So having this odd blend of expertise, I'm constantly sitting next to a controls tech as a commissioning guy. So I was a commissioning guy for 17 years or so. So I'm constantly sitting next to this guy, and you feel so helpless because you can't do, the manipulation to get into the system and just extract what you want and do the overrides that you want. You have to work through him. And this guy, depending on his attitude towards commissioning guys, they're either cooperative or obtuse. So, right. So they'll help or they're not. They'll help or they'll hinder. And I eventually, I got to the point where I was like sick of the ongoing commissioning issues log that would go on for years and years, and then eventually, if you do your job right, you're hated. There's several people that hate you on every job site when you're the commissioning guy. Everybody smiles in your face, but they all do not like you in most cases. So I just decided, I want to be that guy. I want to be the controls guy and be the solution, and apply all that I know, because a lot of controls techs are unfamiliar with all of the sequences of operations that are available, and sometimes they're misapplied. Some guys do know a lot, but in most cases, they're whatever's on paper is what they're giving you, right or wrong. I like to be a little more, diplomatic in the application of the sequences, because you may know a lot more, but you don't want to project that you know a lot more. You just want to say, hey, well, what do you think about this? And or I've heard in this situation that we might want to do this or that. I try not to say, you're an idiot, we should do this because, and that doesn't go over well, and that makes you even more hated on the job site.
You're a nice person. There's not many of them in our business, I've got to say.
I was going to say, for our listeners, this is...
I very much enjoy the controls work because it seems very much like, you are the solution. I mean, you can have the best building, the best design, but if you have bad controls, it's all goes downhill.
So let me explain that.
So I very much like the controls.
So the reason you like that, I think, is you have technical power over other people, i.e. you have knowledge that other people don't have, and the controls engineer or integrator is the person necessary for everyone else to do their job, right? So, there's in your earlier, before you wound up at that place, I guess, as a commissioning person, as an engineer, you realized you didn't have actually the knowledge or the technical power.
Oh, man.
Right?
I realized that 100%. Yeah. Like when I was reviewing control submittals, I didn't know what I was reviewing as a design engineer.
Yeah.
And when I would get tab reports, I didn't know what I was reviewing. I just basically looked at what's not within 10%. And we said, well, okay, Mr. Owner, do you want to pay to get this within 10%? Because it's going to cost more money. And they would say, no, we can live with 12% off. And but after getting certified through NEB, to do balancing and then gaining, last 6 years of controls experience, designing control systems and then troubleshooting. I didn't get into much of the install work, but it's all fun. I do little bits and pieces here, but when you get the designation programmer, they don't want you in the field. No, doing things with your hands, so.
Yeah. For our listeners, I got to say right here that a lot of people, they get helicoptered to the top of the mountain Francisco, you've climbed every inch on the way to the top. And you can tell just, by the words you're using and the descriptions, because Adam and I both know, because we've both climbed to the top on our own fruition. And that's how you build the experience and the knowledge that a lot of people don't have. There are a lot of people, and as everybody knows in the engineering world, like you can get tunnel vision, right? Like you get focused on certain things, but to find somebody that's integrated, that understands, and again, we haven't really got into the interview here, but there are individuals that understand the building science, there's people that understand the mechanical science, there's all of that. But when you start getting into control systems, that's a different league.
Yeah,
there's no doubt about it.
It is.
Yeah, you're Francisco. You are what I call, what's the algebra, Francisco? It's like professional engineer, commissioning engineer, plus programmer, right? That plus that. So if you turn it into a Venn diagram, in the middle is someone who can actually do something. Right? I don't mean that flippantly, but it is flippant. But and to be clear, all controls engineers are not created equal. There are some that just have the programming knowledge,
right?
And what I call software jockeys, but they don't have the applied engineering to understand what they're manipulating at the end of their programs, right? The sweet spot is someone who has the applied engineering and the controls engineering knowledge and can integrate that together, right? Because I believe controls engineers are integrators, right? They're systems integrators. They make the systems in the building, and a building is a system of systems, right? Work together, integrate together, and control, and hopefully over time optimize, right? Now that's easy to say. That word salad was easy to say, but to actually deliver on that is very, very unusual.
Yeah. Well, you said something about the difference between a swing check and a flow check. Yes, right. So, lots of people can sit in front of a computer and they can make things dance, right?
Yeah.
But in line, on the dance floor, there's everything from flow, temperature, and pressure controls, and then all the control devices that go along with that. You clearly have a knowledge of not only the sequence and the orchestra, as it were, but you understand the music and everything else that goes along with it. So it's pretty cool.
I gave a talk at the ABC annual meeting just before COVID. It was 2019. And my topic was like the future of commissioning and balancing, right? Where's it going? So there's about 150 people in the audience. Like half of them were like me and Robert Gray, like starting to think about retirement, and the other half were young, like you, right? So my talk was about this Venn diagram, right? So I believe the commissioning engineer of the future is going to be have engineering skills, controls engineering skills, be able to write algorithms, and in the middle of that is where a highly paid, highly skilled person is going to live, and that is the future of commissioning, I believe, because technology is going to take balance away in the end. So I've been thinking that for 40 years, but at some point that's got to happen, right? There's nothing like balancing a massive toilet exhaust system to make you realize you don't want to be a balancer, right? Am I right?
Yeah. Oh, yeah.
I did a high rise once on my own, and I thought at the end, I'm done. This is just, that's a hard out for me.
So the work wasn't bad. It's the people telling you the system's ready to commission or to balance, and they're still putting equipment in. They're still installing, and they said, "Well, how about you balance the other half of the air handler while we install this half?" And I was like, "It doesn't work like that. We need to
get angry when you want to leave site, right?"
I know.
So I think what you represent is, so when I gave that talk in Texas, the half of the room that looked like me and Robert were going, "Oh," and the other half were going, "Yeah," So it was really interesting because you could see the demographic divide there, right? So my other message in the talk was, if your age begins with a 5 or a 6 or even a late 4, you're good, carry on. But if your age begins with a 3 or an early 4, you're going to see this evolve, in my opinion. And you're actually the first person I've met who sort of is the walking, talking embodiment of that. And I think that is where the high-paying jobs are going to be in the future. So I think you're at the start of a wave. You just don't realize it. But what I want to talk about is your book. So just for our readers, our viewers, our listeners, this book is thick. I could kill a man with this book. I'd say that's nearly 2 inches thick. It is packed full of, it's a book on how to commission control systems, right? And I can't emphasize this enough, it's a how-to book. Because the problem I have with the educational and training system at the moment, there's too much emphasis on fundamentals and not enough emphasis on applied engineering and how-to. The balance has gone out of whack. I think personally, in a 4-year degree, should be half fundamentals, half applied engineering. Because, as an ex-employer, when I used to interview people and they would be all fundamentals and no actual practical knowledge, it used to make me want to cry. And they've been told at college they're going to earn $100,000 a year, and I'm sitting there thinking, they want to give you 30. So there's this disconnect, right? So the system really sucks. So that creates a space for actual practitioners who know what they're doing to disseminate knowledge. And how do you do that? Through books and training, right? So tell us what prompted you to write this book. I'm writing books at the moment. That is not a small task, right?
Well, no, it's not.
So first off, what actually got you into action to do this?
I think what made me put pen to paper was I attended a training on retro commissioning, and I thought that the instruction was poor, and so I came away from that. Yeah. I thought it was very poor, and I said, you know what, I'm going to make something, because they're teaching people to do things incorrectly, and I've learned through hard knocks. I have degrees and things, but you don't need that to do controls work. You just kind of need an open mind and to just leave your ego at the door and just be ready to learn. And so after receiving this poor instruction, I just said, you know what, I'm gonna write a book. And I had the idea sort of brewing in the background for a while, but after attending this training and seeing all the people nodding their heads yes at this poor instruction, and it was specifically related to commissioning of transmitters. So a transmitter, like a CO2 transmitter, puts out 0 to 2000 as the voltage goes from 0 to 10 or 2 to 10 or maybe 4 to 20 milliamps. And so it's a linear equation. So you have to calibrate one of those transmitters with 2 points at least. You can calibrate a temperature sensor with a single point, but a transmitter needs 2 points because it's you're basically checking the equation of a line. And that's how the BAS calculates the reading. Is it takes the voltage and calculates the signal that you want, and you need 2 points because if you calibrate with a single point, there'll be 1 point where you're dead on, and as you get above and below that reading, it'll become more inaccurate. Yeah. So I raised this point during this training, and the instructor says, "Oh, no, you don't need to worry about that. That's only for process." And I was thinking, wait a minute, how is that valid? And he sort of shut me down in front of the whole class. So I was thinking, you know what? I'm going to get this guy.
That's an origin story right there.
I'm going to take care of this guy. I'm going to put out a book, and I actually sent the book to him, sort of anonymously. I didn't say anything, didn't attach a note or anything. I just sent the book to him. So nice. I don't know whatever happened of it, but
did you say, "I see you"? I know it.
Yeah. How about those apples?
Yeah, exactly. But I mean, how long did that take to write? I mean, that's a lot in there.
That's 7 years of my life, of late nights and early mornings. I rarely have, with kids, you don't have a day to work on a book.
Yeah.
You steal away, on a couple. I write best in the morning. I think best in the morning. So I like to get up at 3 or 4, work a couple hours on it while my mind is the freshest. and, unencumbered by all the crap that's going to happen throughout the day. Evening writing is very tough. It's like you're wading through a mud, to try to get where you want to go. So mornings were always the best for me. And but it was 7 years and a lot of work. I think 5 years it took me to write it, and then 2 years of editing it myself before I would share it with someone, because I wanted to be as clean as I could make it before I, let someone else have a look at it. And then even after I sold the first couple books, the people that bought it, they know me. They were my friends, and they wanted me. They wanted to help me succeed. So they read 2 or 3 chapters a day and sent me feedback every 2 or 3 days, and that was, I think, was the cause of the biggest improvement was their feedback. It was genuine feedback by people that care about you. They know you, they're friends with you, and they want to see you succeed. And because there's a lot of people I asked to help and they didn't have time. And it's 400 pages. That's no small thing to review. So I appreciate everybody that was able to put in the time to give me the very valuable feedback, which is and now this book is to be self-published. I think it's very high quality. There's some McGraw-Hill books that, well, I probably shouldn't say them, but there are some big publishing houses that can put out books with errors and mistakes and misspellings too. And I just tried my best to keep that from happening, because I know people that can do half of what you can do, or a quarter. They relish finding a mistake in a work of someone else, and I just didn't want to give them the satisfaction. So
I can tell you, mate, no book's been published without an error or omission ever.
I know.
The history of
just to give you an idea, so talking about McGraw, P.O. Fanger, Professor Olaf Fanger, when he earned his PhD, he wrote a dissertation, and his book, Thermal Comfort, was published by the Danish Technical University. If you could find that book today, by the way, it's probably going to cost you somewhere around between $800 and $1,200 US. It's
really?
an expensive book, yeah, and it's hard to find.
Yeah.
I've got 3 copies. 2 of them are from the Danish Technical University, and those are clean, pure. That's all his stuff. But the book was also republished in the U.S. by one of the big publishing companies, and it's actually missing chapters and pages. Like they took the document, published it, released it, just tossed it out there. People would buy it, not realizing what they've got there. What they have is an incomplete publication.
Wow. Yeah, that's when you get, again, what we're talking about here are books where you need deep knowledge to deliver them, and people want to extract deep knowledge from them. So if you give it to someone who doesn't have that background to edit, right, they go, oh yeah, get rid of that chap, take that out, take that diagram out. No idea what they're doing, right? This is why technical books are hard to read and
no, without a doubt,
find, right?
Yeah, I've written a few books, as you know, Adam, and one. I think this is the second one we hired. The first one or second one, I can't remember now. Anyways, and I hired an editor who was actually with the military, and her experience was in technical documentations. And you know what? She was worth every dime that I paid her.
Oh, I might have to get her number off you actually for mine then, because I need someone to rip me one before I go public.
Oh yeah, and it was big bucks. The book itself was, I think, only 260 pages or something. It wasn't 400.
Yeah.
So, but she did just an unbelievable job. And then I wrote a third book, and then same thing. Francisco basically relied on colleagues to do the editing and the commenting on it, and it could probably use some more work, but
there's also a point where you've got to stop polishing and put it out, right? And if you think about it, it's even Ayn Rand used to say, whenever she started writing, all of a sudden she felt she needed to hoover the house, clean the windows, anything but get on with that book. So there's a procrastination there, right? Put yourself out. So first off, I want to say kudos for getting up like Jacko Willock at 4 a.m. and doing some work. And 2, really kudos for bloody doing it. Actually, that's 400 pages. That is hard work. Now, what I like about it is it's actually about how to. So was that a deliberate choice for you to make it a how to do something?
Yes, very much so. Because, with spending so much time with so many different controls techs at my side as the commissioning guy, I might have browser access to the control system, but I never had programming access, logic access. So now I do. But back then, I had to rely on the guy next to me. And what I noticed is that, as we're commissioning the jobs, it was my own style, I guess, to commission all the components. I was like, because I learned early on, it's like you if you have a failed system or inter-system test, a lot of times, more than half the times, I think it would boil down to a component that wasn't installed correctly, located correctly, calibrated correctly, or wired correctly, or some impediment that failed a system test, and they usually wound up being a component issue. So I said, well, we're going to test all the components first. So we just go by, BI1, BI2, BI3. We disconnect them, we test them, and then go, through with the analog inputs as well, and then binary outputs and analog outputs. And once all your inputs and outputs are confirmed to be, totally functional, then you can rely on the graphics and the data that they're providing while you do your system level tests. So if you just jump into system level tests, you're not sure of your component data, you're not sure of your system level test, then you just have even more to wonder about. Whereas if you test all the inputs and outputs first, you eliminate those components as the source of the system level problem. So that's why I came up with a procedure, because I noticed everyone is doing it differently. So you sometimes you get a tech and he has a college degree. Next time you get a tech, he has a high school degree, lots of field experience, and he's better than the college educated guy.
I'd take that second person all day, every day.
So I noticed there's just such a difference in the way that they would test and check out all the components. And then the other thing I noticed was that a lot of people, they only tested what they were equipped to attest. So I'm not going to say the name of the control company, but we were doing a job where a high pressure switch, we were dealing with high temperature hot water. So the water's 400 degrees, 350 PSI, something that's really
dangerous stuff, right?
Dangerous stuff. So we were testing a high pressure switch. So in the discharge of so this high temperature hot water was used to make pool, it was made to heat the water in the pool, and it was made also to heat the building hot water. And so both of them had a high temperature, high pressure switch. And I said, well, okay, it's time to test this high pressure switch. How did you test it? He says, well, I didn't. I said, you didn't test it? And he said, no. He says, I don't have the equipment to test it. And I said, I'll bring up, I have a hand actuated calibration pump. I brought it the next day. We took the pressure switch off the pipe, pumped it up to 100 PSI. It actually went off at like 93 or something. It went off too early. So we kept, adjusted it so that it would trip at 100 PSI consistently. Then we reinstalled it. And I said, well, what did you do because you didn't test the high pressure switch? He said, well, we have a pressure switch downline, and I put some logic in there that would kill the system if that sensor reading got above 100 PSI. But it's downline. So to get 100 PSI downline, you're exceeding 100 PSI at the discharge of the heat exchanger.
Right.
So, that was one of the, I guess, pivotal memories that said, you know what, I'm going to come up with a procedure. And, you know, some people will say it's right. Some people will say it's wrong or overkill or underkill, but I'm going to put out something that we can use as a starting point.
Well, that's
and you can adjust as needed.
Yeah, that's a high consequence situation, right? That totally justified. And I can almost hear Robert's brain going, high exergy solution. Why did they use steam to heat that pool? Am I right?
The energy part of me, yeah.
Yeah. From the energy equation, steam. I mean, reason for our international listeners, there are a lot of steam systems in North America, in the US particularly, because there is a legacy, an infrastructure legacy of steam systems, right? And there's also a lot of doing what we've always done. So the US is quite unique where it has a high number of steam systems. That notwithstanding,
high pressure water systems too.
Yeah,
a lot of government buildings were done, with high pressure, high temperature water systems.
Mm.
There's a very few people left that they also had pneumatic control systems. Most of those too.
I've done a few steam systems, and my takeaway is, one, I always wind up burning myself somehow, and two, I am terrified of them, and I just don't want to do them. That's my big takeaway from steam every time I get involved in it.
The Edifice Complex will continue in just a moment.
Can you find the drawing and supporting documents you need in less than a minute? Now you can with Echo. It's simple. Just type what you're looking for and press enter. Echo knows your building. Speak with a drawing specialist today. Ask about our special offer of painless onboarding plus 6 months free with Echo. Visit podcast.thedsoffer.com. That's podcast.thedsoffer.com.
And now, back to the show.
I want to try and slay a few sacred cows here, right? So, quick fire question on some control stuff, right? Do controls need calibrating in the field? Yes or no?
Yes.
Right. Agreed. 100%. So we need to, I think, as an industry, as a commission industry, we need to message that better, because every client I ever meet thinks control systems come out of the box, all good to go. And every controls engineer I work with, I say, let's pick on someone, Johnson's. So whenever I go to the Johnson's guy and say, I want to calibrate that sensor, he said, what do you mean? It's control calibrated in factory. Why are we doing that? So we've got to message that better. The other one for me is point-to-point checks from device all the way back to the graphic at the head end, right? If that graphic's not like hooked up, I ain't interested in that system. You know what I mean? Now, do you find in your daily work you wind up having to push through these arguments and get these things done?
Well, in my current capacity, I'm doing the graphics and I'm doing the point-to-point, so it's not an issue for me. But as a commissioning agent, I would have to rely on the fact that the controls contractor did it. And one of the things that I was most surprised about, I've worked for 3 controls companies now.
Yeah.
And what I'm most surprised is that the definition of calibration is different.
Yes.
So for design guys, commissioning guys, it basically means you're going to take an instrument and compare your calibrated instrument reading to what the BAS is saying the reading is. To a controls guy, calibration is going up to the CO2 sensor and saying, okay, yep, it's 0 to 2000, and 0 to 10. Check my analog input, 0 to 2000, 0 to 10. Yeah. I'm calibrated.
Yeah.
And there's never an instrument involved. So that's kind of why I made the point, I think in chapter 2, that there is no calibration without a reference reading from a calibrated instrument.
Thank you.
But yeah, so I mean, I'm still surprised because I don't know how many commissioning meetings I've gone to as the commissioning guy and said, yep, all these inputs and outputs are calibrated, right? That's what I get. Yep, yes, sir. Yep, you have the readings? No, sir. Never had the reading. They may have the point-to-point checkout, but there's the calibration readings are basically kind of a listing of what the BAS said at the time, and no comparison reading. And
I've had a real world example of that. It was actually American Air Base. So I went there and everyone was complaining it was too hot. Yet all the wall thermostats, so the boxes were showing like 21, 22. So we just got a load of calibrated handheld thermometers and just went around and checked them. And they're all about 2 or 3 degrees out. So we had them just all recalibrated in situ, fixed it, took a day. But there was like 6 months of aggravation, phone calls, I'm going to sue you if you don't fix this going on, right? And all it took was me, a technician, and 2 calibrated handheld temperature things to fix that problem, right? And so, why did that have to get that far? That's the question, right? No owner ever says, give me a job, I'm okay with 2,000 defects. I don't care if you haven't done the controls, you can do that after I move in. Said no owner ever. Yet that's exactly what they get, right?
Yeah, that's it.
So I blame the owners for this because they accept it, right? If I accepted a car like that, if I went and bought a new car and the guy said, here's the punch list, 20 items, we'll work it out in the first year, have a nice day. I'd throw them keys at him so fast and walk out, right, with my check. But we don't do that on buildings. So I think the controls industry has a job to do, and the commission industry as well, in communicating somehow to people at the higher level that buildings aren't plug and play, systems aren't plug and play, and we have to have that period of real testing, validation, point-to-point checks, calibration checks, and tuning, right? And the rub is, if you're Turner Construction, that's the last thing you want to hear, right? Because you want to hand that job over. So, have you had any breakthroughs or any advice on how to do that?
Nothing specific that comes to mind. I mean, the only thing I can think of would be just education of all the participants in the industry. I mean, I guess this book is sort of an indictment on, not an indictment, but it points out what we're not doing correctly. Yeah. As far as the controls guys are concerned, there's not enough calibration happening before commissioning, and even in commissioning agents, there's lots of room for those guys to up their game too, because I hear of controls techs, making fun of brand new commissioning guys that are testing and with odd methods that will clearly not work, but they just kind of gather around and watch him, just for the humor of it.
It's like watching a monkey trying to do Rubik's Cube, right?
Yeah. So one of the last stories
I've used the word illiteracy many times. Some people get offended by that term, but exactly, Adam. Too bad. Like we have to belly up and say, listen, we have illiteracy in the industry in many aspects, and there's illiteracy in commissioning, there's illiteracy in controls, there's illiteracy in engineering, there's illiteracy in even understanding human physiology and psychology. It relates to architecture, interior enclosure design, mechanical. Like there's just illiteracy runs rampant in our industry. And until we admit that and call it what it is, we'll never solve the problem. We'll keep producing what we've always produced, right? So, So we're not offended by anybody that says that there's illiteracy. Our people, we need to smarten up. There's no doubt about it.
So that's a good segue to another point, which is training, right? So, if you're 18 and you're thinking about what you want to do for a career, you think, okay, I'll do an electrical engineering degree or go to college and study that, or mechanical. But you can't think, okay, I want to be a controls engineer, right? The pathway to that is really obscure and zigzags like crazy. So training, I think, is another major gap in the industry, and making like controls engineering, an actual choice would be really nice. I don't know how to crack that nut. Any thoughts on that?
No, nothing immediate. I know there's lots of training providers that are coming online, that are online already. But to get into controls, I don't think it's as simple as just saying, okay, well, I'm going to get into controls, because you have to also understand the systems you're controlling. So, you can turn anything on and off. But when you start talking about modulating things and control of humidity and CO2 and temperature and pressure, and those are items that you would probably learn over time. And my path kind of required me to learn all that, because I started out as a design engineer. So I designed systems and then analyzed the energy impact of, it was an ESCO that I worked for. So our job was to find energy savings in the mechanical systems. So I would find the mechanical savings, and I'd go out just about every place with a water guy, or, he would find all the water savings, and then a lighting guy. So the three of us would, generate three pieces of the pie that would finance the construction project, which would pay for all the upgrades. And it requires you to learn quite a bit. And I don't know if that I would suggest it after having, I like all the knowledge that I have, that I've accumulated by doing, design, balancing, commissioning, controls, but every time you start over, you inevitably go down in pay. You don't start over in a new job doing a new thing.
Boom and up.
So my income is like sort of like a sawtooth. So because when you're a beginner, you get paid. You're like a beginner with some knowledge pay rate. So I kind of wish I had gone the controls route first, but on the other hand, I said, well, no, because I know so much more than just a regular straight controls guy knows. So having a broad background. And so I'm kind of thankful and also regretful at the same time, because I have a lot of friends that are making big money. But I'm just happy, in the field. That's what turns my crank right there, is, hitting that button and the fan turns on, the speed changes, and there's nothing like it. It's you don't get that from the office. So
So Robert, we have here, this is a Peter Simmons situation where there is a massive skill stack and skill set here that is not recognized and valued by the market, right?
Yeah.
So someone with your skills, Francisco, and your skill set and your ability should be earning a lot of money, right? Should be a well-paid job, right? Not saying you should be balling out of control, but you should definitely be earning a lot of money here, right? And somehow the industry has managed to commoditize you. We've got to try and change that. And I think that really begins with, so going back to the education piece, it would be really nice if, say you were to do a mechanical electrical engineering degree, you do 2 years of fundamentals, 1 year of applied, and then the final year is a specialization where it could be HVAC or controls, right? And you could come out of that with electrical mechanical engineering with a specialism in controls engineering. And part of that last year is the how-to. This is a system. This is how you set it up. This is how you calibrate it. This is how you tune it. This is how you do loop tuning. All stuff like that would be actually useful to the market and employers.
Mm-hmm.
It's the sort of thing I was looking for when I was interviewing graduates that I never was offered. Do you know what I mean? So I don't know how we do that, but I think the next step for you after doing something like this is somehow training people and getting that knowledge out there, because any commissioning firm, any large commissioning firm has to have controls commissioning expertise in-house. Otherwise, you're not really very good. You've got to be multidisciplined, right? So I think the next iteration for you might be in a training role where you can disseminate this knowledge so you can be a practitioner leader and also the person who does some training as well, right? So it's like, some of these high-level lawyers, as an example, they have a practice, they're like the Harvey Specters, if you watch Suits, but they also maybe go half a day or 1 day a week and train people at college, right? I always remember when I was at university, now and again, they would bring in practitioners and professionals from outside. They were always the best lectures because they would come in and tell you what it was like to do a job and a problem they solved. I did not fall asleep in them lectures.
No, it's because they all had stitches and bruises and scar tissue from 30, 40 years of job site experience.
Yeah, absolutely. So I think for you personally, you've got to move into a space where you're valued and paid well, and somehow the market starts extracting your knowledge and passing it on. Because having you as being the only guy in a firm who can do this is not a lot of value to anyone except you, really.
Right.
And I think, and your timing's probably pretty good. When you think about the demographics of the industry and the retiring rate of people, our age, we're all leaving, and we're taking with us, of course, the knowledge that we have, unless we've left it behind, and people that we've trained or in publications, right? But there is definitely a void occurring right now. And Adam, we haven't really talked about this. Well, we have, but there's a huge disconnect between owners and owners' representatives and the complexity that occurs in buildings. And of course, there's so many different types of architecture and different processes but the fundamentals apply to all buildings, the science and the engineering, and having the integrated knowledge, as Francisco does, that's, as you've been pointing out, that's a huge value that every day becomes more and more valuable as other people leave the industry. So I think part of this disconnect between, what does it actually take to engineer a building? What does it take to look at the controls, which is just one part of it, right? There's so many if-then statements that go on in an architectural project, right? Property development. And looking at the building that you're in behind you, there must be thousands of devices between the sensors, the control valves, all the conduit, all of the switches, the relays, the transducers, transmitters, gas valves, motor. You just go through the list. There's literally thousands of pieces of equipment in there. So when you think about in terms of commissioning and looking at the component, and then the point-to-point, and then making everything sing and dance, making sure all the if-then statements. People need to understand just how complex that is.
Yeah, that's on the industry. That's on the controls industry for not communicating that well. I think. But look, we're coming up on time here, and we're going to just ask you a couple of rapid-fire questions. But this is good. I just want to congratulate you on it. Great work, and well done for spending 7 years on this, right? But this is footprints in the snow. One of my old lecturers was saying, what are you leaving behind? How do we know you existed? Well, you've solved that, right? This is something you've done. You've put it out there. It is valuable. I encourage people to get it. And it's the sort of thing, it's an aide memoir, right? It's the sort of thing I would use if I was on a site and I came up against a problem and I wanted to just dive down on it on controls wise. It's the sort of thing I'd use it that way. And I think that's part of its value as well as a tool in the toolbox for a commissioning person. So anyway, congrats on the book, man. Great work. And I hope you can take it further with some training and anything else you do. But we normally wrap up with a quick fire question each, right? So my quick fire question to you is, if you and I are similar, apart from the fact you're better looking than me, you and I are similar in that we wound up in our jobs by accident, right? I didn't know I was going to be a commissioning guy till I thought I was going to be a professional skateboarder for first sight till I was about 26. That's how stupid I am. So we wound up here by accident. If someone wanted to be a controls engineer, what would your advice be to them how to go about it?
They wanted to be a controls engineer. Well, I would say you'd have to gain first, I guess, a systems knowledge of the systems that the control systems will be applied to. Like, if you're in process, that's a totally different realm of controls. With building automation, though, and I would suggest learning about air conditioning, heating, air systems, water systems, constant volume systems versus variable volume. And once you get a solid systems knowledge, then I think you'd be ready for the controls. But some people will say, jump in, learn the controls, and just, fake it until you make it. But I think the systems knowledge, like how you have to know how the system is supposed to work, so that odd things jump out at you. So, and you won't learn that unless you know what a system should be doing and how it should be operating, and what's a normal discharge temperature for an air handler, and what's a normal discharge temp for in a heating mode. And that'll depend on, whether you're looking at a multi-zone unit, a single zone unit. I think equipment vendors would probably be good candidates for controls techs and programmers, because they seem to get, that knowledge from the equipment's perspective, but that equipment has to go in the building, and you have to know how that interacts with the building as well. So, I wish I had the answer, but I think it's probably the best answer that I could come up with right now. It's like a lot of people miss the systems knowledge. And I worked with a really good programmer. He knew the programming behind Niagara, and he could make it do whatever you wanted, but he had no idea how to use a psych chart. Yeah. And I showed, I was learning graphics because at that job, all the techs had to do their own graphics. Whereas in my first controls job, we had a team of guys, and all they did was graphics. So when you're done in the field, you just say, hey, I'm done with this project. They'll link everything up. The graphics will look great, and you move on to the next one. But while learning the graphics, I had to learn all this code that I had never had to deal with before. Like how do you make the data that your controllers are pulling from the field show on a computer screen? So I was learning that from scratch. Yeah. And I very much appreciated his instruction to me on how to make the graphics happen. And then I would show him or tell him, about psychometrics, how to use the chart. He thought that, a heating coil in the reheat position would provide dehumidification. And I showed him, look on the psych chart. There's no way that this heating coil does anything to help dehumidification. All it does is add load to the cooling coil. Whereas if it's downstream of the cooling coil, you're gonna continue to cool when your temperature is satisfied, and then your heat coil is going to prevent your overcooling of the space while you're continuing to cool when you don't need it for temperature control. You're using that continued cooling for humidity control now. And then we get into other like design issues where, like, say a unit is too large. Well, having a unit too large is not good either, because especially direct expansion. So when your temperature is satisfied, the unit's going to turn off. When it turns off and you're continuing to circulate air, you're continuing to introduce humid air into the space. You're no longer dehumidifying at that point. And so your temperature is cool, but your humidity is high. And that's no good either. So so these are the kind of design and engineering issues that unfortunately a lot of techs don't have. So
just preventing thermal overlap, simultaneous heating and cooling is a big one. So just for our listeners and viewers, Francisco is on a job site and someone is in the room with him.
Sorry.
All good. It's all good. So, Francisco, my question I have for you has more to do with the ethos of the control person. Like when you look at your own psychology and your own understanding and what motivates you, if you had any advice for somebody who, let's just say you've got, like 10 recent grads that are in the field of buildings and they have an interest in traveling down a road similar to yours, and you wanted to improve the success rate of them reaching the same place that you are in 20, 30 years, what kind of person is that? I mean, not everybody is built, not everybody has the same DNA to be who you are. So how do you help somebody make that decision? Yeah, I have the wherewithal. My mind is such that I can do this journey and be successful. Or yeah, that's not me. I'm going to choose something else. So how do you help that individual understand who they are to travel the road that you did and to be successful like you did with your knowledge?
I would say, if you're at all interested in controls, I would just say jump in. Water's warm. As I said, I got into controls full time about 6 years ago, and I've never been happier. Like it's like you feel like the solution instead of the problem.
Yeah.
Or the guy that points out the problems, and I can do that with the best of them. But I definitely like the control side of it, and because it's really the application of the engineering. You're making it happen, and that's where the fun is. And you can find problems and actually just fix them right away. Whereas when I was the commissioning guy, I'd find the problem and then we add it to the commissioning issues log, and then I'd have to, meeting after meeting, did you fix this thing? And they say no. And then you say, well, when do you think you'll have it fixed? And you put that date on the list, and the next week, and you go through the same exercise week after week after week after week. And but as far as controls, I would just jump in because it's so, you have to have a hungry mind. If you're,
I like that.
If you're not at all hungry and your mind is full, you need to pass on it because you'll probably do a bad job. You have to kind of, I guess, continually want to learn. It's like a never ending thing. It's like I'm learning stuff all the time, which is why I still love controls, because when I felt like I was an expert in design, the next design seems like the last one. And as a design guy, you don't go out on the job site very much. So your home while you're doing your work is in the office. Whereas, when I'm done with this job, it's a public library in Washington, D.C. When I'm done here, I'm going to go take my skills somewhere else. Right. And apply them on a new building, and I'll have a new set of people to deal with, negotiate, and work with to get this next system done. And then when that's done, I'll go to another new site. So it's like it's always fresh, And I don't
know if you guys agree with this, what I'm about to say, but one of the things that I learned in my career was that you have to be able to function in a world of gray. Yes. But understand on the sidelines there is black and white. There is a world of ones and zeros, yes and no's, black and white. But if you live on the sidelines, you'll kill yourself with frustration. You have to be able to understand that the world is gray, and be flexible, be patient, be determined. Mm-hmm. Right. And travel down that center line, knowing that there's a left and a right, but your direction is this way. But there's it's like a control logic. It's like a PID control logic. If you're just thinking in terms of on-off signals, you're screwed.
Yep. That's for sure.
You got to think in terms of, well, there's PI and PID, and that means you're going to meander, and at some point you're going to end up where you're supposed to be, right? But it takes time, it takes patience, and you have to be able to work with that, and you seem like you have that. You're a walking PID, on off, analog, digital. That's your brain.
I tell you what, more and more in the controls world, we're doing so much more integrated or packaged equipment. Yeah. And I'm here. There's a commissioning agent here working with me, and so we're going through a sequence for a DOAS unit. And it seems to me like our designs are getting more sloppy. It's like you used to have a point chart and sequences of operations, and on this job, the equipment was specified. There's no sequence of operations in the design plans, and there's no point list in the design plans. And I'm like, well, I said, look, all I can do is, I can serve up these backnet points and make them look nice, but, and I do some limited testing to try to understand, is this sensor actually the sensor at the discharge of the unit, or is this sensor at the discharge of the coil? So there's a lot of, you're dealing constantly in gray matter with integrated equipment. And you also have to realize that you're not going to commission this system to nearly the exactness or accuracy that you would if it were fully programmable and controller by take your pick of any controls vendor. But when they provide all the logic, you have access to all the logic. And with I'm commissioning an Aeon unit. In Aeon units, they have this modular service tool. It's like a little black box that you can connect to the RTU, and you can see what it's configured to do. You still don't see the logic, but you can change all the set points. You can change some of the logic. It's like a fully configurable air handling unit. And but from the commissioning standpoint, there's only so deep that you can penetrate into the logic. So you can't fully prove what it's supposed to do, and you can't fully prove that it's not doing other things that it shouldn't be doing. So also, and it's sort of like black box.
Shame on that designer for not doing his job properly, right? The designer's supposed to issue a description of operation or sequence of operation or points list. So
it's very common though.
Yeah, I know. And then
when I'm designing the control systems, I'm going through the same issues. Like, well, what sensor do I put here? Because they didn't specify. It's just like the designs are becoming more sloppy.
Well, a lot of controls firms in the US particularly are somehow having the controls logic delegated to them as a task, and they are not insured for it. They don't have the skills to do it properly, and someone's going to get sued to oblivion at some point over that. They do not understand the liability they take on, but that's another chat show. So we should wrap up here now. So we're coming up on the hour. So this is Francisco. Thank you very much for coming on, and I wish you all the best with the book and your future endeavors, man. Well done.
Yeah, congrats.
Appreciate it. Thank you, guys.
The Edifice Complex will continue in just a moment.
Adam, it's time to thank some people who are on our side. Blue Rhythm Commissioning Software.
Blue Rhythm is the commissioning software I've been looking for. Most projects I consult on suffer from poor information and document management. Frankly, it's just chaos out there. Blue Rhythm removes this chaos. It is a secure, always available cloud solution designed to work on any computer, tablet, or smartphone. Their Android and iOS apps allow seamless transition between online and offline work. But what I like most about Blue Rhythm is their painless and fast onboarding process. Their team will bring all your existing forms and checklists into Blue Rhythm for you, or you can use or adapt their pre-built, pre-functional and functional performance test sheet templates. But it's more than that. It enables collaboration, automation, and easy planning and project management for all your projects. Blue Rhythm provides amazing support from a team that really understands your industry. To find out more, go to bluerhythm.com or call country code +1 612 460 8305. Also, you can hear from Blue Rhythm President Andy Martin on episode 26 of the Edifice Complex podcast. Robert, we there yet? I'm bored.
Adam, I know it's hard to believe, but the future has finally arrived in Canada.
How's that then?
Well, smart remote building and equipment management is now available from SensorSuite.
Go on.
SensorSuite, yep, they're an innovator in smart building technology. We like them. They can monitor, control, and optimize anything in your building, saving you time and energy.
You mean SensorSuite are moving Canadian buildings into the 21st century?
Yeah, I know, another hard thing to believe, but they're doing it, and they're saving owners money with efficiency gains.
Okay, I'm in. How do I find out more?
Got to go to sensorsuite.com or call 1-855-773-6767. And also check out the July 2020 episode of the Edifice Complex podcast and listen to SensorSuite CEO Glenn Spry.
And now, back to the show.
Adam, another awesome interview. They're all, as I said before in the past, they're all awesome. What I liked about this one, of course, Francisco is, literally put his heart and soul. When you write a book, it's just, you pour it all out, and some people can crank them out in a relatively short period of time. Some people it takes a couple of years. It took a couple of years for the books that I've written.
Yeah, me too.
Yeah, you've got a couple on the plate too, and but that book that he's got there, which is 400 some odd pages, and it's deep, but it's for a practitioner. There's very few books like it out there. It's a really a gem, and I hope there are listeners that are interested in the subject matter. You pick that book up. There's very few like it.
A training course out of several chapters of this book, quite nicely. If someone said, right, okay, join our firm, and over the next 3 months you're going to do 1 day a week, and we're just going to work our way through this book, and it's someone like Francisco coming in and going to instruct you on it. That's what you need, right? That mix of site experience and structured training, so you can go to site. I had this in my early sort of career, thankfully, where I could go to site and get flummoxed by something, and then I'd be in college 1 day a week, and I could go, what about this? And vice versa. I could go to college, have some guy explain something to me. I'd be like, what? Then I could go into work, and someone could really explain it to me in language I could understand. That was, I didn't realize at the time how valuable that was, because you had somewhere to go where no one was going to go, oh, you really didn't get that? Are you stupid? People just went, yeah, sure, do this, and it was great, right? So you came out as a useful, confident human being at the end of it, and I think that's been lost a little bit. So I really love. When I met Francisco, we met at the Orlando Sixth Energy Conference, and he came up and told me what he was doing. He said he was having trouble sort of like getting the message out on his book, and I was more than happy to help by getting him on a podcast. But when he gave me the book, I was like, whoa. And that is like, it's not like something I half-assed over 2 weekends. You know what I mean?
No. And then, a book like that, like the way to open and get into a book like that is consider the book and the author as a mentor for your career. And even though you may never actually meet Francisco or actually get to work with him, I mean, if you can work for a guy like that, I mean, that's hugely valuable. But a book like that is a mentor, and he used the term "hungry mind."
Yes, that was so on point.
Yeah, it really was. And I think if you go into that book with a hungry mind, you'll get an appreciation for Francisco's mind and extract out of there the value that book brings. And what's he selling the book for? How much?
It's over $100. That's why we're working with him to sort of relaunch it and get it into a better format where you can get it off Amazon, print on demand. And I think it needs to be below the $100 mark to make it work. I know why he's done $100 because it's over 100. It's way over $100. I think it's about 160. I can't remember now. But it's got a lot of color images in it, and that really does pump up the price. And you could do it with black and white images just as well, and make it more affordable, and then also distribute it electronically and make it more accessible. So I'm doing some work with him at the moment about how to do that. But at the moment, it's a great book that needs distribution sorted out and the message getting out, which is what we're helping him with, right?
Yeah. I think when you look at books, and And it's the same thing with speaking engagements, isn't it, in many ways? Because when you put a fee out for something and someone they look at the price and they go, well, holy crap. But what they're not understanding is that what you're getting in the case of Francisco is, 30, 35 years of experience, 400 pages of how-to stuff.
$100 years work. Right.
It's cheap, or not cheap. It's good value. Cheap is not the right word for that, because it's not cheap. It's actually hugely valuable. And the price per page and the price of knowledge that you get, you think about it, right? If that 100, whatever the book sells for now, and whatever you guys are working on and getting the price to where you think it should be, if that can solve one page, solves one problem on one job.
Yeah,
that's
a great equation, actually. If you got one takeaway out of here that unlocked a problem and got you forward or something, that's worth it, right?
Absolutely, it's worth it.
Yeah, I mean, this is the sort of book that should be part of a training course or a college course.
Yeah, absolutely.
And then it becomes an aid memoir. I mean, you and I got books on our shelf that I go to occasionally, but when I go to them, I get something out of them that I need. Right? That's the point. It's like a reference. It's like having Google. It's like Google, but made of paper.
Well, as you know, I've sort of liquidated. I have not in the sense of selling, but in the process of moving and over the years, I've gotten rid of 2 or 3 libraries, and what's left in my library are a handful of very valuable books. Some of them valuable in the sense of money, but other ones valuable in the sense of the information that they've brought to my career. And we've mentioned this book many times, and the individual Robert Petitjean's Total Hydronic Balancing. I'll never get rid of it. I mean, I can't. That book changed my knowledge and my career.
Well, he's the first one. I saw him speak when he launched that book, and he went into Valve Authority, which is where you and I bonded. And I still, whenever I talk about Valve Authority, my mind immediately goes back to him talking about it and just going on the board and working it all out. And you couldn't disagree with a goddamn word he said. You know what I mean? It was like.
Nope, you can't. And so, I think I've got left in my library probably 35 or 40 books left out of hundreds and hundreds that I've given away. And, Petitjean's is one of them. And then I have lots of there from the, 19th century old stuff that,
I love
what? Yeah, it's still, the information is still valid as it was then, 1850 or whatever as it is today. So
I think books are going to become very collectible. I mean, that book collection there could conservatively be worth $30,000 to $40,000. I know that sounds ridiculous.
Yeah.
The Robert Petitjean book is worth $1,200 at the moment on eBay.
Is it really?
You can get one.
Wow.
Good luck getting one.
Yeah, wow, that's amazing.
So, I think that's a little gold mine there, but also it's a great gold mine in terms of reference. But the other thing I'd love to see happen for people like Francisco is the market recognize their value and pay them better.
Yeah.
Right?
Yeah, totally.
So a good commissioning firm needs to deploy let's take a large complex job like a hospital, has to deploy mechanical engineering expertise in their commissioning team, electrical engineering expertise in their team, and controls and ELV expertise in that team. It's a 3-discipline deployment, right?
Absolutely.
Which controls is probably the most effective and important. I hate saying that as a mechanical engineer. That's true. Sorry. But, that's the way it is. And they need to be paid for that. I mean, I think the market will recognize that in time, because it's going to get to the point soon as people retire en masse where the few people that can really do it are going to be known, and they're going to make most of the returns, right?
Yeah.
So anyway, I hope that's how it works out for him. But yeah, I think there's as a career to follow, I'll be following Francisco's career. So I think there's a lot more to come there with him. I think he's on the start of a nice trajectory, personally.
Yeah, I agree.
Right.
Awesome. Well, listen, Adam, always great chatting with you. Always great chatting with our guests. And
Inspirational, man. Francisco.
It really is, yeah.
I wish I was that tuned in when I was his age, I tell you.
Totally. Yeah.
Okay, man. Have a good one. See you in the next one.
Yeah, you too. On the next one.
Cheers. Bye.
You've been listening to the Edifice Complex podcast with Adam Muggleton and Robert Bean. To access show notes for this episode, visit edificecomplexpodcast.com. If you have enjoyed this podcast, please leave us a review on iTunes. See you next time.